All right, part of what we do at the Swiss Re Institute is try to catalyze discussions. And so I hope to do that today in what I want to discuss about artificial intelligence, machine learning, and what I'm going to define more broadly as machine intelligence. But before I get to that topic, I want to talk about something that I think is going to, it's a theme that runs through this discussion. And I'm going to start by teaching you an English word that maybe many of you haven't heard before. It's called skeuomorph. It's S-K-E-U-O-M-O-R-P-H. Now, a skeuomorph is something that is an artifact from a previous process that continues on just because we're used to that being the case. So the classic example is the QWERTY structure on keyboards, which was structured to avoid the jamming of mechanical typewriters. Now, that's not relevant to keyboards. Now, I've noticed when I switch to the German keyboards, I always get confused with the Y and the Z. But that's an example where somebody's tried to address that skeuomorph, so you have this artifact from the past, to try to make the typing more efficient. But I think this is a broader problem in the AI ML community. Let me give you another example. When I first joined a research group right out of my university, email was introduced shortly thereafter. This is in the 80s, for those of you that are old enough to remember. And one of the things that was interesting is my boss, who was an AVP, when he first got email, he would have his assistant print out the email, and then he would read it on paper and dictate the response into a dictaphone, hand it back to her, and then she would type the response. Now again, it's another example of a skeuomorph because he was used to that process before with paper and didn't appreciate the availability of the new capability. Now I think we have a similar problem in this machine intelligence field. And so this is what I want to talk a little bit about today, is how do we think a little more creatively about how to implement machine intelligence into our enterprises. Now, I'm going to be focused narrowly on financial services because that's what I know quite well. And I will readily admit that there are other industry verticals that have been much better about implementing some of these tools already. Now, I think it's important that our definitions are clear when we talk about machine intelligence. And the reason for that is sometimes I find that there's confusion between the technical development people and the decision makers that are using the tools. Now, going back to my example before, I think we're still in this community generally very affected by the fact that for many years, corporations relied on paper to facilitate workflow. So if you had to do analysis, you went and found some paper, you found a book, you read that book, you did some analysis, and then you generated a report. And I find the same thing today. Many of our machine intelligence projects are ones where we have a stock of data somewhere, we download that data into an analysis tool, and then we turn it into a report or insight. And we're not thinking about what's available in this new world. You know, for example, if we shifted our view of data from being a stock asset, where it's just a stock that's saved somewhere, to a flow asset, where we're actually hooking into big pipes of data, and our machine learning is more about pulling out of that flow. And I think this is actually happening now in big tech, but it's still not happening, at least in my industry. So that's one problem. The second problem is often people are not clear about what they mean by machine intelligence. Sometimes they mean logistic regression. And that's a perfectly fine approach and makes a lot of sense, but it's not necessarily machine learning, not necessarily artificial intelligence. The other question is, when we're talking about artificial intelligence, what do we mean? Are we trying to replicate the human brain? Are we trying to do something new, say via swarm intelligence? Or are we just imitating a very simple process that may not have required as an advance of an approach that we're implementing? So these are some of the things that I think we should be thinking about. And then the final point is it's important that I think that those of us that are involved in this arena in large enterprises like insurance companies, we figure out how to do a better job of leveraging human capability in an end-to-end machine learning or machine intelligence-enabled process. Because humans are still pretty good at adapting, we're very good at being imaginative, and picking up tacit and subtle cues. And these are not well reflected in many of our machine algorithms today. Now, why is it that I'm even talking about this? Well, it's because there's this huge promise in industry, in insurance, as we shift from this paradigm of understanding and cover, which again is this stock notion. So I just understand the risk, I underwrite that risk, I sell insurance, and then I wait until a claim comes. That is shifting to, let me figure out on a more regular basis how to predict and prevent. That gives me the ability to offer more services, and I can even do a better job at underwriting insurance. And we do have some examples of pilots that seem to be working using specific kinds of machine learning. So that's whether automated claims processing, automated document processing, or automated pricing. So we do have some examples where this is working. Unfortunately, when we look across the broad set of industry in this space and even beyond, we find that machine learning and AI is still falling very short of its promise. And in fact, if you look at a couple of recent surveys, 88% of AI projects, in this case 2017, didn't progress beyond the experimental stage, and Gartner estimates that over 85% of AI projects fail. Now, in insurance specifically, and I haven't done any rigorous research in this context, but insurance specifically, I think if your criteria for success is productively transforming the enterprise, most of these projects fail at a rate in the 90%. And I'd love to have people argue with me about that later, if you have data. But my own experience is most of them fail. Now, that doesn't mean that the algorithm failed. It doesn't mean that you didn't even meet the objective. What happens is somebody may fit an algorithm, and then the business leader says, great, let's put it into our workflow. Now, all of a sudden, a bunch of other things arise. We don't have the right licenses for the data. The data doesn't come in regularly enough to be useful. We haven't thought clearly about the data visualization, so the decision makers don't know how to incorporate it into their decisions. These are all examples of why there's a problem. And if you look at the Gartner hype cycle, what's quite disappointing is many of these tools, NLP, deep learning, a lot of the machine intelligence that I'm talking about is now on the trough of disillusionment. And in enterprises, that just means that you're having lots of creative destruction. And I think that's an opportunity for many people who want to think about how to do a better job of making these types of tools work in institutions. So the first thing is that we need to change the misconception among non-technical people that AI works the same way the human brain does. It typically doesn't. And most of the times, algorithms are hyper-narrowly focused. And in fact, they might not even be the super innovative deep learning or deep reinforcement learning. It might just be logistic regression. And I think it's in our interest to educate the decision makers a little more about the differences. Secondly, often the output is not well integrated into existing decision processes. This goes back to this notion of a skeuomorph. People are not taking advantage of the new capabilities that come from things like Hive intelligence. And I think we should be communicating more what the opportunity set is. The other thing is, often these projects are run like regular IT projects where you don't think carefully about the project team structure. And it is just another tool to be implemented. Algorithms tend to still be quite opaque, and it's often the case that we're not clear about how they've been trained. And the other thing is really about matching the tool with the use case. And then a bigger issue, which I think is great for all of us at this conference, is just the demand exceeds the supply for good people in this space. Now, how can we address this problem? Well, I want to propose that there are 4 AIs we should be discussing more than artificial intelligence. And so I'm going to spend the last part just going through this somewhat quickly as a way to spark a conversation. So the first one is we should be shifting our view from artificial intelligence to augmented intelligence. And I think the important point here, and I won't have time to go through the details of this, these slides are available after my talk if you'd like to look at them, but we should be doing a better job of synthesizing unstructured data for analysts who can use that in preparation for whatever the analysis that they're doing. That's an augmentation approach that I think is much more effective than trying to replace the analysts, at least in a risk assessment role. The other thing is, it's clear when you look at surveys of people who are using these tools that they still want more training, they want more technology, and the point is they want their job to be augmented, not necessarily replaced with the algorithm. And I think you will find, at least in enterprises, in financial services, that will be more productive and more profitable than just trying to go to full automation. And there's lots of great tools for doing that now. Jupyter, Binder, MLflow, just a few examples. So augmented intelligence, that's an AI I think we should be thinking more about, and that has a design component. Second, and I'm flipping the letters a little bit, but intelligent automation. Second AI I think we should be talking about. If you think about data as being the oil for machine intelligence, whether that be regressions or deep reinforcement learning, we should be investing more time in thinking about how we intelligently automate the data component. And that means that we should be focused a little better on the data and ingestion and in curation capability. In particular, we should be building tools into our upstream data processes that look at things like data range possibility, relational plausibility, and even pattern plausibility. And often in enterprises, I find this is something that's not done. The machine learning programmers are doing the data cleaning before they calibrate their model and deploy it, but the enterprise, when they try to deploy, aren't spending enough on the data component. I think we also should be developing more of a notion of a machine intelligence ops capability. We have lots of things around DevOps, but not much around MI ops or AI ops. And this is about really building more of the background and the structure into these capabilities. And the other thing is that, I just took the example of underwriting. If we try to take humans entirely out of the loop, often when we shift to fully automated underwriting, and I've been familiar with some experiments, we miss glaring challenges, like we miss exclusions, or we misprice something because there's a tacit piece of information that the algorithm didn't pick up. And we should be thinking about how do we put humans into the loop intelligently. The third AI we should be spending more time on, assessed intelligence. Now, I graduated from UC Berkeley and taught there for a while, and in 1962, Aldous Huxley gave a great talk where he talked about how our business, and he was speaking to academics, is to be aware and then use our imagination to see what might happen, what might be abused. And I think this is an important, it's an important notion to keep in mind. Because if we really want to do a better job of implementing these types of tools into enterprises, we need to be constantly assessing how they work. What is the algorithmic risk associated with them? Are there biases that are being generated? You know, these are all topics that I'm sure that are clearly on the schedule for this conference and others. But I think the important point about assessment is performance is only one dimension. And in many cases, in real enterprises, I may take systems and algorithms that are slightly worse on performance because they do a better job at giving me diagnosability, robustness, the ability to avoid certain types of attacks, et cetera. And then finally, I think we should be driving toward more adaptive intelligence. Now, this is really where we start having the machines move more toward to where human beings are. And I think this is some very specific recommendations for approaches. I think it's about using hybridization, taking things like physical models, hybridizing them in the context of reinforcement learning, and bringing in other tools such as data augmentation and behavior mimicking capabilities. These are actually research threads that we at the Swiss Re Institute and many of our partners are working on. So I just put these up because I'd love to talk to more people about this. And then the final point that I want to make is that we need to be shifting to a causal inference paradigm to create more adaptive intelligence. And I believe this is really the new frontier for figuring out how to take these types of algorithms and putting them into enterprises to make them much more successful. So in conclusion, if you walk away with only a few points from this talk, I'd like you to just remember, figure out what machine intelligence you're putting in place or recommending. Figure out how is it that we can keep humans in the loop and then use these 4 AIs, whether it be augmented intelligence, intelligent automation, and assess that intelligence. And then finally, I'd like to see us build more adaptive intelligence. And I look forward to that journey with all of you. Thank you.